Hello student, I am Guruprasad Upadhya, H.O.D, Department of Mathematics, Canara Engineering College. So we will discuss in this lecture Module 5, 18MAT31. In that first part, that is numerical solutions of the second order differential equation by fourth order Runge-Kutta method and Milne's method. So in these two methods that we discussed for the first order differential equations, to solve the first order differential equations. How we can use these two methods to solve the second order differential equations? The first one is fourth order Runge-Kutta method. In this, y double dash, that is function of x, y and y dash, is given, and y at x naught, that is y naught, and y dash at x naught, that is y naught dash, is given. Then how to find y at x1 and y dash at x1 by fourth order Runge-Kutta method? Consider y dash is z. So this y dash dy by dx is z. Then y double dash is dz by dx. So dz by dx is y double dash. So that is phi of x, y, y dash, that is z, x, y, z. Now dy by dx, that is function of x, y, z, x, y, z, z is nothing but y dash, y dash means dy by dx, that is z, therefore f of x, y, z is z. Now extend the formula for the fourth order Runge-Kutta method k1, k2, k3, k4 for three variables x, y and z. Let h, k and l are increments in x, y and z respectively. Then k1 is h into f of x naught, y naught, z naught. L1 is h into phi of x naught, y naught, z naught, because L is increment for z, dz by dx is phi of x, y, z, therefore phi of x naught, y naught, z naught. Same k2 value h into f of x naught plus h by 2, y naught plus k1 by 2, z naught plus L1 by 2. This is x, y, z value. And L2 is h into phi of x naught plus h by 2, y naught plus k1 by 2, z naught plus L1 by 2. And k3 h into f of x naught plus h by 2, y naught plus k2 by 2, z naught plus L2 by 2. Here h into phi of x naught plus h by 2, y naught plus k2 by 2, z naught plus L2 by 2. And similarly k4 and L4, that is h into f of x naught plus h, y naught plus k3, z naught plus L3. Here h into phi of x naught plus h, y naught plus k3, z naught plus L3. After finding these k values and L values, substitute in the formula, that is y1 is y naught plus 6 inverse, k1 plus 2, k2 plus 2, k3 plus k4, and similarly y1 dash is, that is z1, y1 dash is z naught plus 1 by 6 of L1 plus 2, L2 plus 2, L3 plus L4. Now I am going to modify this formula. Here f of x, y, z is f of x, y, z is z. Therefore f of x naught, y naught, z naught is z naught. Instead of taking z naught, I am taking y naught dash. Therefore this is f is replaced by y naught dash. So k1 is h into y naught dash, k2 is h into y naught dash plus L1 by 2, k3 is h into y naught dash plus L2 by 2, k4 is h into y naught dash plus L3. Therefore instead of taking this f, directly take the value of f of x, y, z, and instead of taking z you take y dash. So the formula becomes k1 is h into y naught dash, k2 is h into y naught dash plus L1 by 2. Here this is multiplication, not function, h into y naught dash plus L2 by 2, k4 is h into y naught dash plus L3, and L values are same. Now here see this, instead of z in the previous formula use y dash, then f of x, y, z is nothing but y dash, that is z is nothing but y dash. Therefore if h, k and l are the increments in x, y, y dash, instead of z I am taken y dash, the formula becomes like this. And then find y1 and y1 dash. That's all. Only thing is, no need to take the f of in that formula. Directly use the z value, that is y naught dash plus L1 by 2. So that you substitute and simplify. Okay. Example. Using Runge-Kutta method, solve d square y by dx square equal to x into y dash square. Dy by dx is y dash square minus y square for x equal to 0.2. Correct to 4 decimal places given that y at 0 is 1, y dash at 0 is 0. So h increment in x is 0.2. Now h is 0.2, y double dash is x into y dash square minus y square. Therefore, your phi is phi of xy y dash is xy dash square minus y square, x naught is 0 and y naught is 1 and y naught dash is 0. Let h, k and l are increments in x, y and y dash. K1 is h into y naught dash. Y naught dash is 0. H is 0.2. 0.2 into 0 is 0. K1 is 0. L1 is h into phi of x naught, y naught dash. Phi of x, y dash is nothing but x y dash square minus y square. So x naught, y naught dash square minus y square. Therefore, substitute in this formula x, this is 0, 1 and 0, 0, 1, 0. So 0 into 0 square minus 1 square, that is minus 1, minus 1 into h minus 0.2. This is L1. Next, K2 is h into y naught dash plus L1 by 2. Y naught dash is 0, L1 is minus 0.2, by 2 is minus 0.1 multiplied by 0.2, that is minus 0.02. L2 is h into phi of 0.1, 1 and minus 0.1. Why it is 0.1? X naught is 0, h is 0.2 by 2, that is 0.1. 0 plus 0.1 is 0.1. K1 is 0. Therefore, y naught is 1. 1 plus 0 is 1. And here, that we just calculated here, that is minus 0.1. X, y, z or x, y, y dash. X, y dash square. That means 0.2 into, bracket open, 0.1 into minus 0.1 square. So it becomes plus. So 0.1 square, 0.1 into 0.1 square minus 1 square. So that is minus 0.1998. After calculating K2 and L2, here for the next step y coordinate is y naught plus K2 by 2 and the third coordinate is y naught dash plus L2 by 2. Therefore, L2 by 2 plus y naught dash K2 by 2 plus y naught, that you find out and substitute it. This is same, that is 0.1 only. X naught is 0, h is 0.2, 0.2 by 2 is 0.1. Therefore, K3 is h into y naught dash plus L2 by 2. Y naught dash is 0, L2 by 2, that is minus 0.0999. After calculating K3 value, L3 is h into phi of x naught plus h by 2, y naught plus K2 by 2, y naught dash plus L2 by 2. This is same, minus 0.0999, this one, and y naught plus K2 by 2, that is 0.9900, and x naught plus h by 2 is 0.1. Phi of x, y dash is nothing but x, y dash square minus y square. So 0.2 into 0.1, so inside the bracket 0.1 into 0.0999 square, minus square is plus, and then minus y square, that is 0.99 square, and close the bracket, we get this one. So after finding L3, K4 is h into y naught dash plus L3, y naught dash is 0, so h is 0.2, 0.2 into minus 0.1958, so that is minus 0.0392. Then L4 is h into phi of x naught plus h, y naught plus K3, y naught dash plus L3. Now x naught plus h is 0.2, y naught is 1, 1 plus K3, therefore it is 0.98, K3 is minus 0.02, therefore it is 0.98, and then 0 plus L3, L3 is minus 0.1958. Phi of xy y dash is x y dash square minus y square. Therefore, 0.2 into, inside the bracket, 0.2 into 0.1958 square, minus square is plus, and then minus 0.98 square, close the bracket. You get this L4 value. After calculating K values and L values, substitute in the final formula. Y1 is y0 plus 6 inverse, K1 plus 2, K2 plus 2, K3 plus K4, that is 0.9801. So y at 0.2 is 0.9801. Y dash at 0.2 is minus 0.1970. So this is how we can use the fourth order Runge-Kutta method to solve the second order differential equations. Now, one more example is y double dash is y plus xy dash, x naught is 0, y naught is 1, y naught dash is 0 at x equal to 0.2. Phi of xy y dash becomes y plus xy dash, y plus xy dash, and x naught 0, y naught 1, y naught dash is 0. K1 is h into y naught dash, y naught dash is 0, h is 0.2, therefore it is 0. L1 is h into phi of x naught, y naught dash, that means y means y naught plus x naught into y naught dash, y naught is 1, 1 plus 0 is 1, 1 into h 0.2, that is 0.2. K2 is h into y naught dash plus L1 by 2, 0 plus 0.1, that is 0.1 into 0.2, that is 0.02. L2 is h into phi of x naught plus h by 2, y naught plus k1 by 2, and y naught dash plus L2 by 2. This is 0.1, and 1 plus 0, that is 1, and here it becomes 0.1 because L1 0.2 by 2, here 0, so 0.1. And then phi of xy y dash is y plus xy dash, y is 1, 1 plus 0.1 into 0.1 into 0.2, that is 0.202. This is L2. And similarly, K3 h into y naught dash plus L2 by 2, this is 0, L2 by 2, substitute, and then you will get 0.2 into 0.101, so that is 0.0202. L3 is h into phi of x naught plus h by 2, y naught plus k2 by 2, y naught dash plus L2 by 2. Now this is 0.1 and y naught is 1, so 1.0101, and L2 by 2 plus 0, that is 0.101, this one, and then 0.2 into y plus, y means 1.0101 plus 0.1 into 0.101, that is 0.2042. This is L3. Next, K4 is h into y naught dash plus L3, 0 plus this L3 value 0.2042 multiplied by h. So h is 0.2, therefore it is 0.0408. And L4 is 0.2 into phi of x naught plus h, y naught plus k3, y naught dash plus L3. So 0.2 phi of 0.2, 1.0202, and L3 0.2042. Next step is 0.2 bracket open 1.0202 plus 0.2 into 0.2042. So that becomes 0.2122. After calculating all these values, y1, that is y at 0.2 is y naught plus 1 by 6 of k1 plus 2, k2 plus 2, k3 plus k4, substituting. So we will get 1.0202, and similarly y1 dash, and hence y at 0.2 is 1.0202 and y dash at 0.2 is 0.2041. So this is how we can solve second order differential equations by fourth order Runge-Kutta method. Next one is Milne's method. So you know, in Milne's method, first initial four values are given. Then how we can find the fifth value? That means y at x4, y4. To find y at x4, that is y4, from y double dash equal to phi of xy y dash. Y double dash is phi of xy y dash, and four values of y and four values of y dash are given. Initial four values: y at x0, y at x1, y at x2, y at x3, and similarly y dash at x0, dash at x1, y dash at x2, y dash at x3 are given. First calculate y1 double dash. That means double dash is here, phi of x1, y1, y1 dash. That is y1 double dash. Similarly, y2 double dash, y3 double dash. So substitute x1, y1, y1 dash here, and similarly x2, y2, y2 dash in this function, and x3, y3, y3 dash in this function. First calculate y1 double dash, y2 double dash, y3 double dash. This is first step. Then use the predictor formula. Actually, predictor formula for y4 is y4 plus y0, y4 equal to y0 plus 4h by 3, 2y1 dash minus y2 dash plus 2y3 dash. That you know. And hence y4 dash is y0 dash plus 4h by 3, 2y1 double dash minus y2 double dash plus 2y3 double dash. First calculate y4 dash by substituting these values here, and then calculate y4 by substituting the given values y1 dash, y2 dash, y3 dash. Substitute the value, find y4 dash and y4, and substitute y4 use this value y4 dash and y4 in this y double dash to find y4 double dash. So y4 double dash becomes phi of x4, y4, y4 dash. Y4 and y4 dash we just calculated. Substitute here. After calculating y4 double dash, use the corrector formula. That is y4 dash is y2 dash plus h by 3, y2 double dash plus 4, y3 double dash plus y4 double dash, and y4 is y2 plus h by 3, y2 dash plus 4, y3 dash plus y4 dash. Now here actually we know these two predictor and corrector formula for y4 we know. With the help of this, we are able to write the predictor and corrector formula for y4 dash also. Just to take one derivative extra. Y4 here, y4 dash, y0, y0 dash. Here y1 dash, y1 double dash, like that. Same logic here. After calculating y4 double dash, use it here. Y2 double dash, that we already calculated, 4 into y3 double dash, and this new y4 double dash, that is y4 dash. After calculating y4 dash, y4 is this corrector value, y2 plus h by 3 into y2 dash. So that is given, y2 dash is given, y2 dash plus 4 y3 dash plus y4 dash, that is new value, corrector value of y4 dash, that you substitute. So then you will get the value of y4, that's all. So y4 dash is corrector value. So you can reduce your one work. Actual procedure is after calculating this y4 dash, y4, again you substitute in this y4 double dash, again do it once again. That means you are going to use corrector formula repeatedly, but in your syllabus only one step is enough, no need to repeat this. So example, using Milne's method, obtain an approximate solution at the point x equal to 0.4 of the problem. Y double dash plus 3xy dash minus 6y equal to 0, given that y at 0 and y at 0.1, y at 0.2, y at 0.3, y dash at 0, y dash at 0.1, y dash at 0.2, y dash at 0.3 are given. So these are all given values. Now first step is write x0 value, x1, x2, x3, y0, y1, y2, y3, y0 dash, y1 dash, y2 dash, y3 dash. Using that and using this formula, y double dash is 6y minus 3xy dash. Take this right side, 6y minus 3xy dash. Calculate y1 double dash, y2 double dash, y3 double dash. That is the first step. X is x0, x1, x2, x3, y value y0, y1, y2, y3, y0 dash, y1 dash, y2 dash, y3 dash. And then use this formula, y double dash is 6y minus 3xy dash. Take this to right side. So y double dash is one side. So it becomes 6y. Here minus 6y, it becomes plus 6y minus 3x dy by dx, that is y dash. Now substitute y value, x value, y dash, y value, x value, y dash value here. So you'll get y1 double dash. And similarly 6y, 6 into this value y2 minus 3 into 0.2 into 1.258, that is 6.0734. Therefore, you calculate first step is calculate these three values. After calculating y1 double dash, y2 double dash, y3 double dash, verify this by substituting x, y and y dash value in this formula. Okay, after calculating y1 dash, y1 double dash, y2 double dash, y3 double dash, use the predictor formula. y4 dash is y0 dash plus 4h by 3, 2y1 double dash minus y2 double dash plus 2y3 double dash. That means y0 dash, this one 0.1 plus 4 into h, increment in x is 0.1, 4 into 0.1 by 3 into 2 times of 6.0311 minus 6.0734 plus 2 times of 6.1062. So we got the value 2.5268. And then y4, y0 plus, y0 is 1 plus 4 into 0.1 by 3, bracket open, 2 into y1 dash, this one 0.6955 minus 1.258 plus 2 into 1.873, that is 1.5172. After calculating the predictor values, substitute these values here. 6 into y4 minus 3 into x4 into y4 dash, that is y4 double dash. x4 is 0.4, x3 is 0.3, x4 is 0.4, 6 into y4, so this value 1.5178 minus 3 into 0.4 into 2.5268, that is 6.0702. After calculating y4 double dash, use the corrector formula. First calculate y4 dash, y2 dash, here y2 dash is 1.258 plus 0.1 by 3, y2 double dash, here plus 4 into y3 double dash plus y4 double dash, substitute here. After calculating y4 dash, now find y4, y2 is here 1.138036 plus 0.1 by 3 into y2 dash 1.258 plus 4 times of 1.873, and then y4 dash, you take this value, not this one, y4 dash, new one, because we already got the corrected value, use it, we will get 1.5123. Followed now? So this is y value at 0.4, y at 0.4 is 1.5123, y dash at 0.4 is 2.4771. One more example. Here y double dash is 2 e power x minus y. Y double dash is 2 e power x minus y. So first find y not, y1 double dash, y2 double dash, y3 double dash. X values are given. X value here 0, 0.1, 0.2, 0.3, x0, x1, x2, x3, and y value 1, 1.205, like that, and y dash value y0 dash, that is 2, and y1 dash, that is 2.1002, like that. After substituting all this, now substitute x, y, z value, x, y, y dash value in y double dash, that is 2 e power x minus y, 2 into 0.1 e power 0.1 minus 1.205, that is 1.0053. Similarly here 2 into e power 0.2 minus 1.4201 and 2 into e power 0.3 minus 1.6454, that is 1.0543. After calculating y1 double dash, y2 double dash, y3 double dash, predict value of y4 dash is y0 dash plus 4h by 3, 2 y1 double dash minus y2 double dash plus 2 y3 double dash. y naught dash is 2, 2 plus 4 into 0.1 by 3, bracket open, 2 into 1.0053 minus 1.0227 plus 2 into 1.0543, that is 2.4129. y4 is, y naught is 1, 1 plus 4 into 0.1 by 3 into 2 times of y1 dash, that is 2.1002 minus y2 dash, that is 2.2015 plus 2 into 2.3052. So that value is 1.8812. After calculating the predictor values of y4 dash and y4, use this here, find y4 double dash. So y4 double dash is 2 e power x4 minus y4, 2 into e power 0.4, x3 is 0.3, therefore x4 is 0.4, 2 into e power 0.4 minus y4, just we calculated 1.8812, that is 1.1024, y4 double dash. Use this to find the corrector value of y4 dash. Corrector value of y4 dash is y2 dash. y2 dash is 2.2015 plus 0.1 by 3 y2 double dash plus 4 times of y3 double dash plus y4 double dash, this one. So this is y4 dash. After calculating y4 dash, y4 is y2 1.4201 plus 0.1 by 3 into y2 dash. y2 dash is here 2.2015 plus 4 times of 2.3052 and then y4 dash, new corrector value y4 dash, that is 2.4129. Substitute here and simplify, you get 1.8813. So this is corrector value, name value. So y4, that is y at 0.4. Okay. Now one more example, using Milne's method, find an approximately the value of y at 0.4. Here in table it is given x0, x1, x2, x3, y0, y1, y2, y3, y0 dash, y1 dash, y2 dash, y3 dash. So y double dash is 2x minus y dash. So y double dash is, so x value, y value, this is given, y dash value is given. Now find y double dash value for y1 double dash, y2 double dash, y3 double dash, substituting x, y dash value. 2 into 0.1 minus 0.8952, that is 1.0952. Next 2 into 0.2 minus 0.7813, that is 1.1813. 2 into 0.3 minus 0.6592, that is 1.2592. After calculating y1 double dash, y2 double dash, y3 double dash, use these values to find y4 dash. y0 dash minus 1 plus 4 into 0.1 by 3, increment is 0.1 in x, h is 0.1, 2 times of 1.0952 minus 1.1813 plus 2 into 1.2592, that is minus 0.5297. y4 is y0 1 plus 4 into 0.1 by 3 into 2 times of y1 dash, 2 into minus 0.8952 minus 0.7813 plus 2 into minus 0.6592. Use that sign plus or minus that properly, that is equal to 0.6897. Use these values to find y4 double dash. 2 into x4, that is 0.4 minus y4 dash minus 0.5297. So y4 double dash is 2 into x4 minus y4 dash, 2 into 0.4 minus 0.5297. So we got 1.3297. Use this to calculate the corrector value of y4 dash, that is y2 dash plus h by 3 y2 double dash plus y4 y3 double dash plus y4 double dash. y2 dash here y2 dash minus 0.7813 plus 0.1 by 3 y2 double dash 1.1813, 4 times of plus 4 times of 1.2592 and then plus this value 1.3297, that is minus 0.5297. This is corrector value of y4 dash. Here also same, no need to worry. Now y4 is y2. y2 is 0.8213 plus 0.1 by 3. y2 dash is y2 dash minus 0.7813 plus 4 into minus 0.6592 plus minus 0.5297, that is 0.6897. Here also we got the same value. So verify all these using calculator. Okay, nothing is there. Very easy to remember this formula because we know the formula for first order differential equation, that you are going to extend for the second order differential equation by substituting y4 dash and y4 dash corrector value. Same type for the predictor and corrector value for y4 and y4 dash, same type, but one dash extra here. That's all. Okay, now we discussed all the concepts of the second order. That means in the syllabus it is given only these two methods. One is Runge-Kutta method to solve the second order differential equations. In the fifth module, the remaining part is calculus of variation. So I am going to discuss in another two videos about that calculus of variations. Thank you for it.